All right, here's just a quick review of composition functions. And the way to think of a composition function is almost like at a factory where every person working on the line does something different to a product. And then at the end of the day, you end up with something useful. So it could be a piece of metal that someone drills holes in, the next person puts screws in, somebody bends it, somebody weld something to it, and then, at the end of the day, you have a piece of a grill or something like that. And so the purpose of this function over here is to square. So whatever, in a sense, we use a variable, but really what this variable is saying is whatever you sub into the function, you're going to square it, no matter what it is. So if I sub in 3, yeah, I'm going to square 3, and I'm going to end up getting 9. But I also could sub in x plus 1 into the function, which means I take whatever I have, which is, in this case, is x plus 1, and that will end up getting squared. And again, maybe the person wants it simplified, maybe not. Okay, this function over here says add 3 to whatever you have. So again, I could say, just kind of leave a box, but of course in mathematics we don't like to put boxes, we use variables. But it's take whatever you have and add 3. So again, of course, if I sub in, say, 7, I'm just going to add 7 plus 3, and I'm going to end up with 10. But I also could sub in, say, whatever, x plus 1 again. And if I sub that in, take whatever you have plus 3. So I have this. That's what's getting subbed into the function. And then the function adds 3 to it. And so I get x plus 4. So composition functions says this function does this first, and then you're going to put it into another function to do the next step, kind of like the assembly line idea that I was talking about earlier. So order matters here. Okay, so what this means is I'm going to sub x into g first, and I'm going to get an answer to that, and then that answer is going to go into the f function. Sometimes you might see that written like that because your first input is going to be this function, and it's going to go into that function. All right, so what's the g of x function? That's just x plus 3. All right, so it's x plus 3. So really, you have f of x plus 3. And that is going to get shoved into your f function, which says take whatever you have and square it. So I'm going to take what I have, which is x plus 3, and I'm going to square it. So that's the composition function. Now, if I change the order, that is also going to change my output. So if I do this, all right, this means I want f of x first, and f of x is going to go into the g function. So I'm going to start out with f of x, and that is going to be my input to g. So f of x is x squared, and that is going to be my input into g. Well, g takes whatever you have and adds 3. So I have this, and so that's my output. So with composition functions, if you have a lot of functions in a row, for example, my input here is x. But when I put it into the g function, my output is x plus 3. So, but then that output becomes the input to the next function, which gives me this. And again, you can have a long string of compositions, but it's, again, like that assembly line. If I'm the first person, I might cut the metal. That my input was a sheet of metal. My output is maybe a piece of the metal. That becomes the input to the next person. The next person drills holes in it. So their input is a smaller piece of metal, but what they do is drill holes. So their output is that smaller piece of metal with holes in it. That becomes the input to the next person who maybe puts screws in it or whatever. That's kind of the idea of composition functions.